Question 10, this one's also pretty simple. 900 kilogram cards at 20 meters per second. Brakes are applied, comes to a stop, average power. Most important thing to take away from this is the car comes to a complete stop, which means the final amount of energy is going to be zero, right? Because it's going to be kinetic. The car was moving, and there's no spring. It's not going up and down. There's no gravity, so it can only be kinetic. But one half, and if the velocity is zero because it's not moving, then this whole thing just becomes zero. So energy final is equal to zero. Um, and because we're looking for power, we ultimately just need to find out like these are all watts, which is like unit of power. But for power, it is equal to work over time. So because we're looking for power, right, we just need to get work and then we get time. They give us time, it's 5 seconds, so 5. So now we just need to find out what work is. So work in this scenario is going to be energy final minus energy initial. But again, this is just equal to 0. So work is going to be equal to negative whatever this is. Um, so, now we just have to figure out what the energy initial is. That's just going to be 1/2 mv squared. And that means work is equal to negative 1/2 900 that, and then it's going at what 20 meters per second squared. And then you just have to solve this out. So, uh, this ends up just being what 450. Sorry, 450 times 20 times 20. That gets you 180,000, and then this is your amount of work, right? Equals work. This is how much work you have. Um, and I think that's why they have it as an answer choice, like here, as in like 1800 watts, to like trip you up. But that is not it, because again, we need time, right? So if we just end up dividing this by the 5 they give us, that equals 36,000 watts, and that would be our final answer. So the answer for this one is D. Um, the reason I'm re-recording this one because I made a mistake when I was explaining this earlier. I said it was a conservation of energy question because it doesn't talk about friction anywhere here. So I'm like, okay, it's conservation of energy. It's not. If power is equal to work over time and there's no work being applied, then obviously it can't be freaking power. And if they're telling us there is power, then no, it's not going to be conservation. So for this one, like I would just be wary to not just like, oh, throw this over onto this side. And oh, I'm looking for EF is equal to E0, because then that would give you that what is it? 1/2 900 times 20 squared is equal to 0. What the hell? That's not going to work, right? So don't just kind of assume this is a conservation of energy question, just because they have been so far. It's not. If we're looking for power, it cannot be conservation of energy for the most part. Maybe there's an exception somewhere, but not this one. So, yeah, D is your answer.